Okay, so now let's talk about specifically the z-distribution, which relates to z-scores. And so the z-distribution is a version of the normal distribution, which is called the standard normal distribution, where the scores or the answers or responses. Again, these are all ungrouped interval ratio variables, so the numbers that you get, your data, where those raw scores are changed in such a way that the mean is always going to be reset to 0, and the standard deviation unit is always going to be equal to 1. And the purpose for this really is so that we can tell exactly how far away or how close is a given score to the mean. We can also calculate probabilities and percentages and percentiles. So for example, if we think about the mean is the 50th percentile. Well, why is the mean the 50th percentile? What do we know the 50th percentile to be in terms of definition? We know the 50th percentile to be the median. So why is the mean the 50th percentile? Again, remember, because it's normally distributed, the mean equals the median, which equals the mode. And also, we can use the z-distribution and z-scores to compare different distributions in different samples. So if you have a sample or different variables that have different means and standard deviations, we can compare these. Again, thinking back on coefficient of variation, that was one way of being able to describe and compare the variability and dispersion between two different samples, two different distributions. Z-scores allow us to do the same thing. We look at individual scores and we're able to compare them, compare means and standard deviations using the z-distribution. A given score on a normal distribution is expressed as a number of standard deviation units away from the mean. So this is what we call z-scores. So z-scores are essentially the standard deviation unit. And so this is the formula we're going to use to calculate our z-score, to see how far away are individual scores away from the mean. And so our z-score formula is that x is the individual score, x bar, the sample mean, and s is going to be your sample standard deviation. You can notice this is all about individuals and samples. So taking a look at this z-score formula, the only difference is that this is related to the population. Again, we're using Greek symbols here. Population mean for mu, and sigma, which is going to be the population standard deviation. So let's take a look at an example. The average height in a given sample is 68 inches, with a standard deviation of 5 inches. If we pick an individual who is 60 inches tall, that person's z-score would be what? Well, here's our formula. Z equals x, which x means the individual score, so we have 60, minus the mean, which in this case is 68, divided by your standard deviation, which is 5 inches. So we set up 60 minus 68. The difference of that divided by 5 is then equal to negative 8 divided by 5, which comes out to negative 1.60. So in a sample of people where the average height is 68 inches and a standard deviation of 5 inches, if we picked a person from that sample who was 60 inches tall, that z-score would be negative 1.60. Pretty simple. So in the case of z-scores, always round 2 decimal places over to the right. And we'll see why this makes sense soon. So now that we've calculated a person's z-score, what we can do with that z-score is find a person's proportion or probability for that variable. So at this point, that negative 1.60 for the person who's 60 inches tall doesn't really mean much to us in terms of interpreting that. So what we can do is then use our z-score table, which you'll find on titanium. And on that z-score table is going to be a list of proportions and probabilities for a given z-score. And so but these proportions of probabilities can simply be converted to percentages and percentiles by multiplying them by 100. So just think about percentiles and percentages. Just like the cumulative percent column in your frequency tables, that as you move along the answers, you're adding upon more and more and more of these samples. So steps to using the z-score table. Make sure you have a handout available and out. So the thing is, you want to calculate the z-score, rounding it to 2 decimal points to the nearest 100. And what you do is, once you've calculated your z-score, you find that z-score on your handout. Notice that one side of the page contains negative z-scores and the other side of the page contains positive z-scores. You'll want to make sure you're paying attention to that depending upon the z-score that you calculate. So here's an example of what we're looking at. So if we look all the way to the very left column, you'll see z, and in bold, your whole number and your tenths place. So negative 3.4 to negative 3.0, you'll see it goes all the way down to 0. If you're on the positive side, it'll be from 0 all the way to positive 3.4. And then if you look at the first row, this is your z-score, it's going to take it out to the hundreds place. So 0.00, 0.01, 0.02. So the way we look at this is we use the first column and the first row to help us triangulate to find our probability. So once we have the z-score, we find the probability or proportion that corresponds to that z-score. And you'll notice you want to keep all the numbers that are in the table. So keep all 4 decimal points nearest 10,000. So go ahead and find the probability that corresponds with the z-score of negative 3.8. So here's negative 3.1, and we need 3.18, so that takes us to here. The probability that corresponds to a z-score of negative 3.18 is 0.0007. This is your proportion, or your probability, that corresponds to the z-score. We can then multiply that number by 100 to convert it to a percentile or to a percentage. And one way we can now interpret this percentile or percentage is that this is the percent of people in the population, or of your sample, who are expected to have a score that is the same or lower or smaller than that individual's score. Or you can say it as the percent of people who you did as well or better than. Okay, so here is an example. I've given you 5 z-scores. Go ahead and use the z-score table to find the corresponding proportion, and then convert those proportions and probabilities to a percentage. Go ahead and pause this video, work through the problem, and then unpause it to see if we got the same answers. Okay, so let's see if you got the same answers. We have the z-score already for us, so we don't need to even use this formula. So what we do is then just take the z-score table and we find the corresponding proportions or probabilities. Hopefully you got these numbers. And then once we have the proportion or probability, all we do is just multiply them by 100 to get your percentile, or to get your percentage. So notice that as the z-score number increases in the positive direction, so does the percentage. We see that the z-score of negative 2.37 is only 0.89%, whereas a positive 2.85 is 99.81%. But also notice the z-score of 0, equal to 50%. And again, this is indicative of how a z-score is equal to 0, and since we've reset it to 0, this is also equal to the mean, the median, and the mode. So one way we can think of this again is that these are all percentages. These are all percentile ranks. So you can say that if you had an MCAT score of 30, which corresponded to some z-score, you can say that you're smarter than 74.3% of all of those who had taken the test. Again, thinking about cumulative percent in the frequency table.